Okay, here we go. I think we are now operating as expected. Thanks so much for joining us, everybody. Give me some feedback on the audio levels. Everything has been moved around because of the live stream last week, but it looks like the level is coming in pretty hot on the mic. Maybe I just need to keep it close. Okay. Drew, Ed, HR, end of cycle. Thanks everybody for coming in here. Quantum Space. If you're out there in the chat, give us a shout out. Let us know you're here. And this is Voltage Control Lab. VoltageControlLab.com, at Voltage Control Lab on Instagram, at VControlLab on Twitter. And today we're getting into a little bit of Hemisphere Suite exploration, deep diving in, messing around, seeing what we find. You know, let's goof around, see what falls out. Okay, audio stream bit rate problems. No, okay, we'll see if that is a problem. All right, Dallas, thanks for showing up. Lionel. All right, here we go. Sounds like I'm hearing a ringing bell. Uh-oh. Oh, maybe that's the synthesizer. Let's tell me if that went away. Maybe not. His is significantly louder. Okay, let's see. Just fine-tuning here. Let's see. Check. I might not be as compressed as I'd like it to be. I also don't want to just blast everybody out of the water, but let me know if you hear any clipping, any problems like that. I just don't want to like clip the signal coming into the mic or coming into the audio interface. But okay, let's try it out. Okay, there's some signal bleed coming through my my mute device, I think. We'll have to play with that. Okay, here we are. I'm getting messages. Okay. So we're going to look at Hemisphere Suite today. Just so you know, next week on Thursday at 4 p.m. Pacific Standard Time, I'm going to be doing a live production session on the Musicians Institute YouTube page. So, yeah, I think we're only sending mono anyway today, so hopefully that's going to work anyway. But, okay, enough of the audio-related side notes here. Let's get into the nitty-gritty. And, yeah, so just a couple of notes. Next week on Thursday, 4 p.m. Pacific Standard Time on the Musicians Institute YouTube page, we're going to do a 2-hour compose a track from scratch. That should be a good time, and looking forward to doing that. That's going to be mostly probably in Ableton. So if you are a diehard modular head, there might not be too much modular in that episode or in that show, but it should still be a good time if you want to come and check it out. What else? Looking into getting a Patreon going. I'm working on getting my Bandcamp going for the next big Bandcamp day. Give you guys updates on all that. But thanks for coming. Let's get into some Hemisphere Suites. Hemispheres Suite. All right, let's switch over there. All right, a couple of things. Hemisphere Suite has a couple of versions. You know, there's release versions, but there's also a couple of versions of the firmware in its current release. And I have the inverted version installed. So if you're wondering why my module's upside down and all the text is upside down, that would explain it. What else should I mention here? Okay, also, Hemisphere Suite, to save your screen from burning out at some point in the in the future, hopefully, is designed to go blank after a minute or a few minutes. And so if you come to it and it's off, all we really need to do is push something, touch something, turn something, and it should switch right back on into its current state or its previous state, whatever you were previously doing with it. It's going to still operate and do everything that you expect it to do. If you're sending CV in, if you're triggering it, it's still going to operate even if the screen goes dark. I'm to understand. So you can step away from the unit and be working on other things, and it's not going to burn out your screen with that same visual showing all the time. So a handy tweak there. I just like the inverted version because it makes it super accessible for shooting some of these like macro shots that I was getting with the super close up of the screen and the and you'll notice here in this particular case, I've got mostly accessible things for hand operation on this bottom row, and most of those things have outputs along the very top of the module, so there's nothing getting in the way of my hands when I'm playing. And on the top we have a lot of sort of bottom oriented modules, with the exception of my VCA over here. So there's a reason I have this upside down. When you orient it upside down, you're going to, of course, unless you have some specialized panel for this, you're going to end up with a lot of upside down labels that don't accurately represent what these ports are anymore, right? This is now A, this is B, this is C, this is D. So it's all flipped, trigger 1 through 4, CV 1 through 4. It still operates kind of in a left to right fashion in the outputs and inputs, but a little quirky, I suppose, and probably kind of confusing when I'm making videos about it. So just putting it out there. Yes, we have a SoCal Synth Society blank over here. Everybody hit up SoCal Synth Society. Check out Travarsi on the Perfect Circuit YouTube channel. She's been doing a ton of live streams over there. Great stuff. What's the process to load hemispheres on an Ornament and Crime with the regular firmware on it? Okay, so great question. I have a video from a couple of years ago talking about alternative firmwares, in particular on the radio music, and the same process is going to be used here. Basically, they operate in a sense off of the same microcontroller. There's a teensy in the back of each one of these things. So the functionality, the interactivity of the microcontroller to the computer is the exact same. You use a little app. It's like the Teensy Programmer app, I think is what it's called. And there's a link to that, I believe, in the documentation on that video. Basically, we're going to just take the module out of the case while the case is powered. We plug in a micro USB cable to the back. There's a micro USB cable. You can see it on the back of the device. Basically, okay, let's rewind a couple of steps. We download the Teensy, or rather the Hemisphere firmware from the Hemisphere GitHub page. You could just do a Google search for Hemisphere Suite. I'm sure that will be one of the first things that'll come up. You download the latest firmware. It will come up as I think it's an INO file. Is that right? Someone back me up here. It's a Teensy program file, basically, with the modular powered up so that the Ornament and Crime has power. You connect the microcontroller on the back, the USB port that you see back there, there's only going to be one, to your computer. You can probably just double click that thing and it will automatically, you don't need case power at all. You can take it completely out and just run it. I think that's if you've cut the power pad on the teensy, right, Savage? Uh, dot hex. You're right. The teensy has a certain pad for power supply, and if you have cut that, you don't need power, and if you haven't cut it, then you do need power. I might have it the other way around, but if it doesn't work, if you plug it in via USB and it doesn't light up, then you can power it by the computer or by the modular power. Um, and you just double click that hex file. It should open up, I believe, in the um, something or rather. Okay, Anthony mentions he just bought the new Ornament and Crime with hemispheres, and he's not super happy with it. He wish it still had the Quantum app. Okay, that's a great gripe, I think, because I primarily use the Quantum app for my performances, which is a quad quantizer. And the quad quantizer also has a function in it that turns it into potentially a quad Turing machine. Again, we did a video about this a while back on our original series of Ornament and Crime videos. But I don't think there's anything quite like those quantizers in here. There is a analog shift register that seems to have a couple of cool functions associated with it. But there's a dual quantizer, probably not a Turing machine. There's a scale quantizer, of course. That works. I think that's that's like 2 scales, if I'm not mistaken. I'm not sure how you get to the second scale. Ah, there we go. We just have to scan up to the next octave, I guess. So that is, we could use 2 of those, right? We could use the dual quantizer back and forth like that. Yeah, the quad Turing machine is definitely how I use it as well. So in that sense, I don't know that there is really a replacement for that. But I've been more inclined to get a second Ornament and Crime at this point because I want to use both of them together. Let's see. One reason I have 2 Ornament and Crimes. Yeah, one has the original, one has the Hemisphere Suite. I think that's where all this is leading for me as well. But okay. So, what should we look at? Who's got some requests? Hopefully that was, I think we probably got distracted midway through that firmware update discussion, but it's super easy. No, it's not a complicated process in any respect. So, and if you need some help, go back and check out the that video for the radio music firmware. Radio music alternative firmwares, I believe is probably the name of it. Okay, Enigma. Let's look at the Enigma Jr. Okay, and this looks like some sort of note sequencer. Let's, before we do anything else, research might be required. LOFI tape, shift gate. All right, perfect. Yeah, LOFI tape is pretty cool. Okay, let's see. Maybe some sample and hold shenanigans. We'll have to find some sample and hold. I'm going to look up the Hemisphere Suite. Let's turn up the desktop for a second. And, okay, so this is the GitHub for Ornament and Crime. It's probably not the latest version. I think we're on 1.8. Not sure why it took us to this page. I think it was some random old search of mine. Okay, there's the build instructions. We're going to go to the software fix, I think. Is this where it is? No, that's not what I'm looking for. README? That's the same page. This is my one problem with GitHub. Here, let's go to this one. Nope, that's not it either. Okay. Hemisphere Suite wiki, that's probably it. Okay, here we go. Let's show 49 more pages and scroll down through this list of insane stuff. Okay, Enigma Jr. While Enigma imposes a track song workflow. Here we go. Enigma Jr. allows you to organize your Turing machines via CV. It allows playback and temporary manipulation of registers in your Enigma register library. Okay, so this must be related to the full version of Enigma, which is like its own macro mode in Hemispheres. There are some bigger modes in Hemispheres. There are the Hemisphere modes that we're looking at right now. If we look over here, where we have the split hemispheres, the split sides of the module, the left side and the right side, each of which can be unique functions. And then there's these other bigger modes, of which it would seem Captain MIDI is one of them. We did a discussion on the darkest timeline on another show. Enigma we see here, it looks like is aha. So here we go. Enigma is a shift register, aka a Turing machine workstation, designed to enable nearly repeatable full compositions by curating a Turing machine library and chaining Turing machines into songs. Wow. So are we familiar with a Turing machine? Right? A Turing machine is a kind of a randomizer device. A lot of people use them to generate random sequences. And the nice thing about it is you can lock loops of random sequences. So it can generate a creative melody or sequence of notes for you, and then you can lock that sequence into a loop and turn it into a musical cycle. So it's not endlessly random. It plays back something musical, and it becomes musical if it's not inherently musical in a sense. And it also allows you to bit by bit implement random change to that cycle. And it's a really genius concept. I believe Tom Whitwell was the developer of this thing. And okay, let's go back over here. So yeah, and I have to admit, I have not played with this mode yet. So curating a Turing machine library. So I assume that means maybe we can record, capture bits of content that the Turing machine might create, and then maybe organize and reorder those things, save locked loops of these types of things. That is one of the complicating factors with the Turing machine, is that it's just going to kind of randomize and do its thing. And you can lock a certain sequence of notes that have passed through it and been randomized into a loop, but saving that or recording that content to something other than audio is maybe the challenge there. Yeah, Music Thing modular. If you don't have a Music Thing modular module in your kit, you are missing out. They have some of my favorite modules. I use the radio music all the time. The microphony. Maybe we'll plug our new electromagnetic mic that we built last week into the microphony, a previous thing that I built. Great modules that they have, and you can get them in kits, and they're pretty buildable. Okay, so let's move along down here. Enigma's workflow involves 4 screens: library, contains 40 Turing machines. Okay, so now we're getting into the, maybe we're answering some questions where a moment ago we were talking about, oh no, we're without our quad Turing machine functionality in Hemisphere. And now we find out, I didn't know this at all until a minute ago. Now we find out we've got 40 Turing machines in Hemisphere Suite, apparently. As you audition a register in the library, you may change its length, probability, and rotation. These are some of the definable characteristics of the Turing machine randomization and loops, right? Probability, the length of a looping or somewhat looping segment, and then apparently we can maybe like nudge or rotate that sequence around. So the initial note that falls on beat one or falls in a recurring sequence happens in a different point in time in the sequence, if that makes any sense. Assign allows you to choose the function of each of the ornament and crimes 4 outputs. Each output may be assigned to a source track. I assume that means one of the 40 machines, a type, note, modulation, gate, or trigger. So we can send out notes, a modulating signal. Maybe that's like a smoothed version of the signal or something like that. Gate or trigger. So we can use this to send randomized probability-based gates and triggers. A scale to quantize the note material, right? We can choose a scale for each of those 4 outputs. We're talking major, minor, probably many different other types of scales. And MIDI channel, if we're sending via MIDI. One of the other benefits of the Hemisphere Suite is that we can keep our device connected to our computer via that micro USB connection and use it as a MIDI interface, MIDI to CV interface, via the Captain MIDI device, and then apparently through this functionality as well. On the assign screen, you may choose whether you're auditioning the library or the current song. Okay, I'm not sure how the song works. We're about to find out. Song allows you to chain registers together on up to 4 tracks. Each track may contain up to 99 steps for a total of 396 steps. Each step specifies a register, a number of times that the register repeats, the probability of a bit flip at each step, and yeah, you can see there's a how a Turing machine works method below that talks about how it's operating the probability and these types of things. And the transposition of notes played. So you can have a sequence of, one of your locked randomized values, randomized loops, was once randomized and now it's a locked loop, slightly changing and ebbing and flowing, repeating a certain number of times. So, this idea will loop 3 times and then some other idea will come in after that, transposing those things. So you can kind of almost use those Turing machine based sequences as arpeggio patterns. As you play other notes, it will transpose that entire sequence. It's getting insane, frankly. Play allows you to control the playback of the song by choosing clock divide and loop per track, resetting and starting the song. It also allows you to visually monitor the song's position. Okay, so this is basically where we create the ideas, and then we, categorize, order, fine tune how we want those things to play. You probably don't have to do any of that stuff. We can probably just use it as a quad Turing machine just by not playing with the song functionality or things of this nature. But this is very, very deep from what I can tell. Down here it tells us how a Turing machine works. The original Turing machine circuit by Music Things' Tom Whitwell works like this. A random 16-bit number is generated. On an incoming clock signal, the binary representation of that number is shifted to the left by 1. A probability check determines whether the last bit of the pre-shifted number is moved back to the beginning during this rotation, or if it changes its value. So as a certain probability loops back at the end of a certain number of steps, the machine decides whether it's going to change its value or keep it the same based on probability. Then an output value is determined based on the new 16-bit number. Originally, this was the bottom 8 bits scaled to a voltage output. Enigma uses Turing machine-like registers as its source material for composition. In a traditional Turing machine, the starting register is different with each session. So when you turn on the new system or you reset the Turing machine, it's not saving what was done before. It's just going to create a new random sequence. So if your Turing machine hits upon a melody or a modulation pattern that you like, you need to record it somehow, either with an audio recorder or CV recorder. The philosophy of Enigma is that Turing machines can be durable and reusable. When you find something you like, you can lock it in place and save it for later and use it as part of a larger composition. So this is, and that's an if. You can lock it in place and save it for later and use it as a part of a larger composition, but I doubt that you have to. So, okay, let's come back over to the module. Maybe we'll just dive into Enigma first. Hi to everybody who just showed up. Cinematic Laboratory, Sana. Enigma is a big Hemisphere app, and that's where we're gonna go with this. So we were just looking at Enigma Jr, and that kind of led us right back to Enigma because Enigma Jr seems to be a sequencer, kind of like a mini sequencer based on the ideas recorded via or created via the Turing machine full Enigma app. So, and if we look here, let's just choose this. If we turn this knob, see how it's kind of like cycling through like banks and patterns, and each one has a different Turing machine thing on it. It's like 40 different patterns, right? 5 letters, 5 banks, 8 patterns each bank. And let's see. Looks like probability. Whether the output is sending notes, triggers, gates, or modulation. We'll have to try those out. And output D. Okay, these are the output routings now. Are these things sending notes, expressions, modulation values, or gate triggers? I'm not sure what I guess the 3 through 7 or maybe octave ranges. We'll find out in a minute. Okay, so I think we're going to have to go into Enigma to set any of these things up. So let's do that. We can long hold or long press the right hand encoder. And that takes us to those macro modes. These are the big modes. There's Captain MIDI acting as a MIDI interface. Darkest Timeline, which we looked at in another show a long time ago. The Enigma app, Neural Net, Scale Editor. Scale Editor and Waveform Editor might be functions that will affect other modes as well, just like Enigma and Enigma Jr. Ed makes a great point here. This is what he doesn't like. This crosses the boundary. Here, I'd rather choose my own notes. And that's a totally okay outlook. And then he asks, how can we implement music theory correctly otherwise? And that starts getting into one of the functions here in the Turing machine. Well, not in the Turing machine. In a Turing machine, if we had all of these pieces all broken out into a fully modular setup, we would need to send the Turing machine through a quantizer, right? To get the quantizer, or rather to get the scale-based manipulation of what's coming out of there. There. I've removed the maths guy. To get the scale-based manipulation of whatever sequence comes out of the Turing machine, you need a quantizer. But the benefit of ornament and crime is that it has quantizers built in all over the place. So yeah, and I think this kind of comes back to how you like to write. To me, this randomized functionality doesn't have to be for notes, first of all. It could be for modulating anything, creating interesting, changing modulation to all kinds of things. And maybe we'll explore that once we get a register in here. First thing we're going to need is a clock. So I need to send a clock signal over here. And but I think maybe a bigger picture consideration. Okay, so we got a clock in there, and now it's moving. Is that the randomization, in a sense, gives us another way to create things. It doesn't have to be something that takes the place of dictated musical content, melodic, harmonic material, but it can fit within those rules that you create, and it can give you some sort of alternative way of composing. I love using it because, especially for very techno-ish results, maybe some of the music theory flies out the window. You might not need to adhere to music theory if you're making certain styles of music, but I think we'll find that there are ways to make it all conform. So now we have to kind of learn how to use the Enigma mode. So right now, it's doing something. And it looks like we can choose the length of the loop. Let's actually patch this to something we can hear. Let's take the output A, which is D. Let's send it up here. Let's unmute this channel. Whoa, that's really high pitch. Let's turn that way down. Let's see, how are we going to trigger this? Okay, let's take that same signal. Just patching over here, getting things set up, getting a... Okay, let's turn up the probability. We've got a 16-step sequence. We'll bring back maths, don't worry. Thanks for the love for maths. Let me know how the signal is coming through over there. So we're just letting it go right now with a small probability. We could crank this way up. So now probability is at 100%. it's going to be constantly regenerating and randomizing every step. And if we turn that down all the way, it locks it right in place, right? Now this is probably controllable via the CV inputs. We'll worry about that in a minute. We can go back to our documentation. This is kind of what it takes to learn some of these things. Like the functionality is so complicated, potentially. It might need to be learned and used in small pieces as we go, and then we expand the tool set and start to gain a greater understanding of this, right? But the idea here is that we've taken 16 steps. It's randomizing each step as the step passes kind of the playhead, the point at which the sequence is, the step that is currently playing or about to play basically is randomized. All the previous steps are held in place wherever they were, and if we turn off the probability, all of those previously played steps in the 15, other looping steps will be frozen in their positions, and we get a looping sequence of notes, right? We can maybe make this a little bit more apparent by shortening that sequence. So now we've got a 4-step sequence. Is that even, visible? Let's see how close I can get this without going out of... look at that. Much better. Hot damn. I really enjoy these good angles on the on the ornament and crime screen, because my old videos I had to suffer trying to get the thing to show up correctly and focused, and now I got this cheap macro lens, and it's not on right now, but for those videos I've been making recently, I've clamped it on. I can get it right up in there, and it takes up the whole screen. It looks pretty brilliant. So it's, still hard to focus, but okay. So now we see maybe a little bit better. On the left-hand side, we have our library, and I think at this point we've locked in place a 4-step loop. Okay, we see here it says 4 steps. Previously, a moment ago, it said 16 steps. That's why we had that long loop going. And probability P equals 0. If I turn this up, seemed to lock in place there. That might be a bug. Or maybe that, oh wait, yeah, it's 50%, right? That's where it is kind of like the full randomization, right? That's a lot more random. And then if we go to 100% or 0%, I believe, this is kind of going back to how the original Turing machine works, then it will lock in place. Anywhere other than 0 or 100, though, okay, I got the 50 to 100% thing wrong. It's doing like a longer sequence at 100. Clearly I need to read up on my Turing machine functionality here. But I don't think it's a bug, though. So there's the 4-step sequence locked. As we increase the probability, It's more likely to randomize, but it keeps a fairly similar sequence as it goes. We can always lock it. Okay, what if we go down? Now we're on A2. So this is another one in the library. Okay, now we got rotation. Okay, and it said we could choose a scale. Let's see. Oh, we can favorite, it looks like. Is that what that is? Still learning this thing here. It said there was a way to do scales. Let's see. We might have to move to the next page. How do we get there? Oops, let's go back to A1. So there's our 4-step sequence we saved before. Okay, so track 1, 2, 3, and 4. Those are the outputs for A, B, C, and D. Okay, so here we go. We can choose now on this track. Track 1, is that what's going to send out? Or track 2? Which, we don't really have a track 2. Wait, let's go back. Let's go back to track 1. Trying to figure out what the note 3-bit. I guess this is the range. You can hear it's getting wider. Okay, and then here we can choose the scale. The first 4 are our user definable scales. We use the scale editor for those. Off is going to give us an unquantized signal. Semitone will give us chromatic scale. Ionian rather, not ionic. These aren't columns. It's Ionian mode. That'll be the major scale. Dorian, Phrygian, Lydian, Mixolydian, Aeolian, Locrian. These are the 7 modes. To get to this page, great question. I believe I pushed, the left encoder. That switches page. We started out on the library, pushed the left encoder. That takes us to the assign page, and that's where we are now. And here we can choose our scale again. And there's all kinds of crazy scales in here. Blues scale. Major, minor, pentatonic. And those first 4 are definable scales. Well, wow, there's a lot. I think there are a lot more scales in here than there are in the original Ornament and Crime, actually. That's a lot of scales. And MIDI channel, if we want to send this out as a MIDI sequence. That's maybe something for another day. Let's see. And here we can set up, I guess, our... Oh, yeah, okay. So here we can set up our patterns, our Turing machine sequences into a bigger sequence. Okay, 3-bit equals 8-note range, 4-bit equals a 16-note range, 5-bit equals, I guess, maybe 32, or would that be, I guess that would be, yeah, 32, right? Someone likes Aeolian. Okay, but here we can see, we can sequence our patterns. A1, 4 steps, it's telling us. I think that's probability, 0 to 99% probability that it will be there. We can have it repeat a certain number of times. We can have it offset, I guess. Yeah, now this is getting crazy. Looks like you can have it. Oh, this is where you can do clock division or forward and backward performance, I guess. Looping. Pendulum mode. This is pretty crazy. Oh, shit. Okay. Yeah, let's get rid of all those. I think I went crazy because I changed it to 6-bit, yeah. Keep going past. There we go. Give the people what they want. Yeah, it's totally transposition. Okay, so this is insane. This is like days of exploration there, I think. If we come back to, whoops, we're not using that channel anymore. If we come back over here, there's A1, our 4-step sequence, and we can take that clock. We're going to trigger the right trigger. And by the way, just a reminder, if we're not sure what the right trigger is, we can double push this and we can see, okay, digital input 1 is the clock. That's trigger input 3. CV is shift. 2 is organize. I suppose that's scrolling through the different patterns. Output is assignable. I think output, there we go. And then we have 2 outputs. You can see C and D, right? So we don't necessarily need to figure out or set the patterns ahead of time. We can do it right here. In fact, we could just switch to an empty pattern, right? Like one of these ones that we didn't touch. And we can just treat it like a new 16-step Turing machine pattern. And then we can independently change the range. And we could send the smaller range out of output D. Now, we didn't set up quantization for this, so So very simplified mode gives us access to all those different Turing machine functions. It looks like, let's go back to Enigma for a second. What's the longest they could be? 99 steps? 16 steps. Okay. So each one's a 16-step sequence at most. You know, if you want different length sequences, you could set each one of the first 16 you know, table options here to different length values, and that way you can just scroll through them in the Enigma Jr. Pretty interesting stuff. And okay, now we have the clock in a different place too. Whoops. Okay. How about okay, that's pretty cool. Let's take a look at LOFI tape, huh? Okay, let's see. Holon asks, hopefully I pronounced your name right. Holon asks, have we found an easy way to navigate the multiple looping Turing machines? Enigma Jr, I think, is the easy way to navigate them. Trying to do it in the Enigma mode, I don't know that there's an easy way. I think that's maybe the complicating factor there, is that the setup of all of these things in the Enigma mode is, you know, there's a few menus, things like this. It's complicated. Sorry, thought I heard a noise. Okay. Okay, now where were we? LOFI. I think the LOFI tape wants to take in a signal. It looks like it's getting some sort of weird noise in there. Let's select it. Okay, so LOFI tape. Let's do a little research. I'm going to bring it back over here to the desk for a second. Yeah, that was a really interesting direction going down that Enigma rabbit hole. That was a good recommendation. Really weird, useful stuff. 40 Turing machines. Crazy. Okay, let's take a look at LOFI now. I'm going to switch this over to the desktop for a second. And I did try this one previously, but I haven't done much with it. So, audio rate looper for audio or CV. Important. Okay, both digital ins expect a gate signal. Digital 1 pauses playback while the gate is high. 2 records from CV1 while the gate is high. So we're going to have to send a signal into CV1 and record using a gate into trigger input 2. CV ins, CV1 is the signal, which can be audio or CV. CV2 is sound on sound, or the balance between the incoming signal and the looped signal. So this is kind of the wet dry between the dry signal, the incoming signal, and the looping result. A and C are the main output. B or A or C is the main output. B or D is the end of cycle trigger. Okay, and that's going to be handy if we record a loop and we want it to, you know, to kind of go in time with something else. We could use that end of cycle trigger as a reset or something of this nature. resets the buffer and records one complete buffer cycle, about 1 second, sets the end point of the buffer. Okay, so encoder push or encoder turn. So this should be interesting. LOFI records at a sampling rate of 2 kilohertz for 1 second. Incoming signals are downsampled to 8 bits of resolution. So this is called LOFI for a reason. Okay. Let's take a look at this thing. It's clearly got like something blipping across the screen. You know, I think I'm not suggesting that I fully understand some of these things either, but we're just trying to take what we can from the documentation, and we can use, of course, our handy double button press to give us those same settings, like an even more brief description of what those few settings were, and hopefully that gives us a little bit of direction. But digital lo-fi is always crappy. Totally true, Ed. And, you know, if we think about what we normally record at these days, it's 32-bit, 48 kilohertz. That's kind of maybe the standard these days. Maybe 96 or 192, depending on your audio file obsession. But maybe you argue about those things if you're really, really obsessed with it. But okay, we see here digital gate 1 equals pause, gate 2 equals record. We can use our encoder to pressing it will record, turning it will end the recording. So what we need to do is we need to patch our signal into, oops, wrong, that's out, into the input. We need to patch our output to our VCA, somewhere where we'll hear what's coming. And I think we need to control the balance as well. So I'm going to route maybe our unclocked voltage block over here to CV2. Okay, so there's the dry signal. And I can push this. I guess I have to hold it. No? That turns on the shared clock. I guess they did say it's only 1 second, huh? Okay, well here's an interesting consideration. Let's keep the signal connections here. Maybe we'll take out our Enigma channel. No, actually that was doing all of our sequencing, so we'll leave that in here. Here's what I was going to say. Here's what's interesting about this to me, is that if we mix the 2 kilohertz sample rate won't really be a problem for sequences and things like that. Might not make the nicest sine wave LFO recreation, but still probably pretty good. Also the latency on the Ornament and Crime is super, super low. I can't speak to how low it is on Hemisphere Suite because I don't know, but it's that's kind of one of the benefits of the Ornament and Crime is that the latency is less than 100 microseconds generally. So we should get really fast recording. here's the cool thing to me about this, is that we don't have to have anything recorded. In fact, I think, is there a way to clear the... Okay, no way to clear the whatchamacallit, the playhead. But that's okay. It's not playing right now. Oh, yes, it is. Let's just go to the dry signal. I mixed out of the loop signal. So I can loop, and we don't hear any effect because it's all dry signal now. But listen to that dry signal actually dry. Very clean. But through the lo-fi, without any looping. So this is a potential distortion source as well, a potential lo-fi, signal distortion tool, right? I think that's a very useful thing. Of course, maybe a more adept downsampler would be a more flexible downsampler, and bit crusher might be ideal. But there's something nice about this lo-fi character. Like, what if we clocked a drum machine or a drum sequence? This will take a second to set up here, and we will clock. No, wait, we have that clocked. We want to clock this. And then we'll take that signal output. Let's turn down the volume. Okay, there's the signal I was looking for. And then we will choose that channel, randomize it. Okay, so now we're not doing any looping, right? We're just sending this drum signal, which is otherwise pretty clean. Comparatively clean, anyway. So maybe a cool lo-fi tool as well. Maybe, we get some cool lo-fi beats out of this thing. So, it's like a whole lo-fi scene right now. So maybe a fun way to even just send your... might be fun to just send our sequence drums from our DAW into something like that. Or you could just use Redux or something plugin-wise. But something very kind of specific about 2 kilohertz and 8 bits. Okay. Well, here we are. I think maybe we will call it there and save further investigation for a future video, which will maybe come this week. maybe we'll do some further. Someone tell me why the teensy loader says the hex file is too large. That's something you might email the Hemisphere folks about for support. I don't know enough about teensy to know, if there might be a problem there. Boots and cats with Euclidean mode. Okay, let's do that real quick before we go, because that's always fun. Super simple setup, but we have to perform a little bit of that module inbreeding, if you will. Let's tip this up a little bit, kind of like that. Okay, so we're going to choose on one channel the boots and cats. Also, let's just unplug all this stuff for a moment. Boots and Cats is a lo-fi drum kick and snare. Oh, shit balls. Okay. Didn't expect that to happen. My mic. Goddamn. My mic boom arm just fell off. My apologies for those loud bangs. It's not intentional. Okay. Okay, there we go. It's actually not going to fall off again, hopefully. This is what happens when you're constantly tweaking your mic stand. It just slowly moves closer and closer to the edge of the abyss. Okay, so we got boots and cats mode, and we can route those channels out. If we look at this, digital triggers 1 and 2 input are going to be our play functions for our kick and our snare drum, respectively. CV will be attenuating inputs 1 and 2, or sorry, outputs 1 and 2, the kick and snare. Outputs A and B will be left and right if we want a split. And okay, let's take the output A, that's going to be our kick drum and our snare drum. And then we'll have to trigger inputs 1 and 2. Great. We know that. Let's choose, what are we going to use? Yeah, the annular fusion Euclidean rhythm generator. Has 2 channels, conveniently. And we're going to take a clock. That's maybe the first thing we need. It's our clock. Send that into trigger input 3. We can, of course, look at our rule set here and see clock is digital input 1 for this hemisphere, which is trigger 3. And clock A comes out of channel 1. Clock B comes out of channel 2. There are 2 Euclidean rhythm channels built into this, and we can tab through them. The first one is 16 over 4. Next one is 16 over 8. Let's find out what the hell that means. I'm going to take channel 1. We're going to send it to the kick drum. And I don't want to go into the CV input. I want to go into the trigger input. Okay, let's take and we can tab through all these controls. Bass drum tone seems to change the bass drum tuning, not the tone. Hopefully you guys can hear that. Is that loud enough? It's a little bit of a clicky kick drum. Might need a little bit longer attack time, just like a millisecond attack time or something. And then let's get channel 2 going. We need another cable to go from output D to trigger input 2. Oops, wrong one. And set that blend in the middle. That way we get the kick and the snare. And over here on the annular fusion, we can choose our snare pattern. I mean, it's lo-fi sounds. They're not the... The other thing I would love out of, built into this would be the decay to also control the pitch envelope of the kick, of which there is none right now, which kind of makes it sound like a sad kick drum. It doesn't have the oomph of a pitch envelope on the front end of it, and so it's a little bit... It's lo-fi, right? It's just like our lo-fi tape. There's limitations here. And we could rotate our patterns. I like the snare more as a hi-hat too, by the way. Would love to have a little bit shorter decay on that snare so it sounds like a proper hi-hat. Maybe go high, even a little bit higher in tuning. And you can use the CV inputs to rotate the Euclidean pattern as well. So the whole Euclidean fandango is in there. It just we need some CV for some offset to make that really work. I think the blend splits the left and right to channels output A and B separately, and then if you move the blend to the middle, it makes them both come out stereo. So, yeah, the bass drum. There's little things about each of them that I would love to change. Again, this is a hemisphere made by one person who might be open to suggestion. And I mentioned something in the, a quirk in the ADSR envelope in my video this week, and he commented on the video saying he didn't even know about that as a bug and that he was going to go in and fix it for the next version. So, there's room for improvement here and there, and I'm sure that he would be open to your suggestions, which I'm sure you could submit via the GitHub page that we were looking at. Okay, well, I think we're going to leave it there for today. We shall continue with more hemisphere explorations in the future. You can bet on that. Really thankful to see everybody coming in here and hanging out with us today. That's maybe the most people we've had at a time in one of these so far. So really stoked to have everybody together and see all your faces and names and get all your input. Really thankful for you guys sitting through this. And we'll do it again next time. Maybe next time we'll actually get to play around with the electromagnetic microphone a little bit too, because I was getting some fun stuff out of that this week. So, all right. Well, everybody, this is Voltage Control Lab. One last time, give us a subscribe, a like if you enjoyed the video, and the live stream and all that business. We'll be back here next week. We're hopefully going to have another video this week, trying to get back on that regular train and trying to improve the videos bit by bit. I'm not a video guy so much as an audio guy, but trying to get there. So bear with me, and I really appreciate your joining us. Oh yeah, a little bit of dancing maths. Let me. It's like talking to the camera as if I was looking at, the camera was even turned on. Voltage Control Lab, voltagecontrollab.com, Instagram, at Voltage Control Lab, at V Control Lab on Twitter. You can find me at Computo on all of these things. My music is out there on Spotify, and I'm on Instagram too. So hit me up, and we'll see you guys next week. Thanks for coming in. Take care.